Hello guys, in this section I will talk about the proof of diffusion current using Foward bias. First, as we study before we study, we have to know about the summarize about the junction voltage can be modified by applied bias VA. If we get some bias VA, then the junction voltage can be modified by the applied bias VA. Then, because of this applied bias VA, the state, equilibrium state will getting changed into non-equilibrium state. So, in this part, we will know about this state is equilibrium state. Based on these two summaries, we will study about this section. First, in the last class, we know about the electron concentration in p-type semiconductor. Is equation is same as like this, but we will change it to because this part and this part will change into the electron concentration in p-type semiconductor, ordinary. And samely, we can know about we can get this equation very easily. First, this picture is the part of the PN junction. This part is only P semiconductor of PN junction. The first graph is an A and second graph is B. A will change into B when the forward bias VA gets applied. When the forward bias VA get applied, then the junction voltage getting smaller. So the graph A will change into graph B. First, there is a Boltzmann-Tail graph in here. But at first, it must be Boltzmann-Tail graph in the end of semiconductor A. And when get some forward bias and graph B is the same, maybe similar state of Boltzmann-Tail graph is same as like A and B. Because if we assume there is a long semiconductor, then the end of semiconductor will be the same as A and B. Then in this part of, we will assume here is an XP. At first, in graph A, then this XP Boltzmann-Tail will be smaller, little bit larger than in graph A's end of graph A, but because in graph A only this part of Boltzmann-Tail will get easily to move on p-type semiconductor. But when the Boltzmann-Tail and the forward bias getting some p-type semiconductor, then many electron can get into semiconductor, p-type semiconductor. So in the part of xp, we will see only part of xp. And the difference of A graph, the Boltzmann tail will be drawn like this. In the barrier of p-type semiconductor will be very smaller, so many of carrier can move into p-type semiconductor. So there must exist some diffusion current in xp, like here. If we see in this graph more closer, we know about the difference of the concentration, electron concentration. In this part, we will know that this is way, and in this part, the concentration is. So we will subtract this NP, SP, and NP0. Sorry. The difference is NP-XP and NP minus. NP0 is the difference of NP and XP. And we have to solve the diffusion current. Then the diffusion current is Jn is equal Q dN dx, and it is same as, okay, this you agree? Then we know about NP-XP is an NP0 exponential QVA over KVT, and if we solve this equation, we will get NP-XP is equal, this is here, can goes into here. So NP0, okay, is there way? But we lost one thing. If we know about the dn, we have to know about the diffusion length, Ln. The diffusion length, how do we get some diffusion length? There is an equation. So if we change, there is an x is to xp. It means the right shift about the size of xp. So we can know about okay, did you got it? Then we know about this equation. So we will go up this equation about let me think about it. Okay. Is this equation we'll know go into in this section. Okay. Then equation will change into N exponential QA KBT minus 1. Then we will see this equation. Then we will derive to x because of this. Then when we calculate, this is same as above. And if we derive, there's 0 getting 0, and this will be same as before, and there will be come out. So ln np0 exponential qva kbt minus 1 and e x minus xp ln. Then we getting them in this section. Q, dn, ln, lnp0, and exponential qva, kbt minus 1, and exponential x minus xp over ln. It is an Jn, but we want to know about electron diffusion in xp, part of xp. So when we getting some xp in x, so we know we get this equation. It's getting 1. So the Jn is the same as like this, and Jp is similar. So it is can be shown like this. So the total J is Jn plus Jp. So it can show like this. Lp dp pn0 plus dn over ln and p0. This is the total current. We will resolve the diffusion current, total diffusion current using Foward bias. Thank you.